Very good morning, students. In this session, we are going to see conformations, stability, and optical activity of decalines. So, in decalines consist of two cyclohexane rings joined to share two carbon atoms. So, they are having two isomers like cis isomer and trans isomer. Okay. So, whenever two cyclohexane rings are fused together, we have resulted in the cis decalines and trans decalines. So bridgehead hydrogens are on opposite phases, it will result in trans decaline, and bridgehead carbons are same phases, it will result in cis decaline. See, now we can see the structure of decalines. So this one is cis decaline and this one is trans decaline. In cis decaline, the axial as well as equatorial. So these hydrogens are, so these two substituents, here axial and here equatorial. So whenever axial and equatorial positions are blocked by cyclohexane, so it will result in cis decaline. In trans decaline, equatorial and equatorial. So di-equatorial, 1, 2 di-equatorial positions are blocked. So this will result in the trans decaline. Now let us see the stability of and optical activity of cis and trans decaline. So we can compare cis and trans decaline like this. Actually, cis decalines are conformationally mobile and trans decalines are rigid. In cis decaline, they are having 3 gauge butane interactions. So total energy is 2.7 kilocalorie per mole because one gauge butane interaction is having 0.9 kilocalorie per mole. And trans decaline, it is not at all having any gauge butane interaction. So there is no gauge butane interaction and the energy is 0 kilocalorie. And cis decaline optically inactive because it exists as a irresolvable DL mixture, but trans decaline is a optically inactive compound because we can put a plane here, so it's a meso compound. So from this we can find out it's a cis decaline, so it is a mobile, conformationally mobile, and trans decaline, this is a rigid one, and energy here 2.7 and here 0 kilocalorie, and it is optically inactive one. See, from this we can find out the 3 gauge butane interactions. Between C1 and C2 one interaction, and between C1 and C3 another interaction. The final interaction is between C4 and C3. So these are the 3 gauge butane interaction. So from this session we can find out cis decaline is somewhat less stable than the trans decaline because cis decaline is having 2.7 kilocalorie per mole and trans decaline is having 0 kilocalorie. Okay, and trans decaline is a meso compound, so optically inactive, but cis decaline, it exists as a irresolvable DN mixture. This is also optically inactive. Thank you for listening lecture. If you are having any question, you can post to me.